Hey everyone, welcome to our next video. This is going to be, we're going to start trigonometric equations. I may break this section up into like two parts. I haven't completely decided yet. I'm just going to kind of see how long it's taking us and then kind of decide from there. This section is 6.5. It's trigonometric equations. So this section in the old textbook that we used to use actually used to be 3 different sections. And now in this book, it ropes it all into one section. So that's why I think I might split it up a little bit. We'll just see. I'll see how long it takes. So whenever we're looking at trigonometric equations, so I'll put a little note here. When we solve equations, so we're solving for some kind of unknown, we are looking for every x or input value that would satisfy. So for the most part, we're going to be looking at angles. So I'll put a little note here. We're going to be looking at angles. So for our first example, I'm just going to say solve for all values of x. And we're just going to kind of do a bunch of these, but first I'll start off with, I'm looking for cosine x equals 1. So what I'm looking for here is I'm looking for the angle that I would plug into cosine so that I would get 1. There's different ways to do these. There are general solutions that utilize the inverse function. I have to tell you that I don't really prefer that way of doing it and thinking about it. Sorry, there's something on my screen I was trying to get off. I prefer to just kind of think about what the angle needs to be rather than necessarily try to use like a formula kind of method. So what we're going to use a lot today is we're going to look back at that unit circle. So this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. This point here is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So what I'm looking for is what angle does cosine equal 1? So remember, on the unit circle, cosine is the x value. So that's happening right here is where cosine equals 1. So that's happening at 0 radians. So I would say x equals 0. Here's the slightly hard part about it. We have to consider that every angle that is coterminal to 0 would also work. So you want to think about, like, if I plugged in, say, I wrap around the circle 1 time. If I plug in 2 pi, that also works. Now if I wrap around again, add another 2 pi, my next answer would be 4 pi. That also works. And so on and so forth. I can do 6 pi, I can wrap around again, add 2 pi, 8 pi. So all these answers are going to work if you plug it in. So a way that we can write this is we can say x equals 0 plus 2 pi k. So k is an integer. You don't have to tell me that k is an integer when you do these. I'm just telling you that k is an integer. And then you could simplify this a little further and just say 2 pi k. If you left it with the 0, that would be fine as well. I wouldn't worry about that. So the important thing to know here is that 0 works as an answer, but also everything coterminal to 0 will also work. And so we're going to see that as we do these problems, we're going to see that we have multiple answers. And sometimes we have to like add 2 pi k, or you could also write it as, we could have put it in degrees and said 0 degrees plus 360k, and that would have just been 360 degrees k. I don't really mind if you leave it in radians or degrees. I'll take either. Whatever the online homework is asking you for, that's what you should leave it in for them. But for me, I'm not super picky. Let's do another one. So B, let's do cosine x equals 0. So here I'm looking for every value of x that I could plug into this cosine so that cosine would equal 0. So I'll come back to my unit circle. I'm going to erase all the stuff I circled on it earlier. I'm going to bring it down so that I can see it with our problem. Let me move this down with us for a moment. Okay. So I'm looking for everywhere that cosine equals 0. So remember, on the unit circle, cosine corresponds with the x. So that happens here. It also happens down here. So I'm seeing 2 answers here. So I have pi over 2 as an answer. I also have 3 pi over 2 as an answer. What's happening here is I can rotate half a circle and get to my next answer. So if I rotate down here, if I rotate back up here, rotate down here, rotate back up here, I'm getting answers every time I go half a circle. Well, half a circle is just pi. So if I'm adding pi, I can get a new answer. So I'll say x equals pi over 2 plus pi k for this one. In degrees, we would say that this is 90 degrees plus 180k. Again, you don't have to give me both of these answers, radians and degrees. You pick whatever one you like. Now, the equaling 0 is the only time with cosine and sine, actually, that we will add pi instead of 2 pi. We almost always add 2 pi. It's just that when cosine and also sine equals 0, that happens half a circle away from each other instead of having to go around the entire circle. So that's just a little bit of an exception. Now let's say, for example, you wrote me your answer and you wrote it like this. You said x equals pi over 2 plus 2 pi k. So pi over 2 and everything coterminal to it. And then you just wrote me 3 pi over 2 plus 2 pi k. I will accept this as a correct answer. It's not the best way to have written your answer, but it's fine. It's still correct, so I wouldn't mark it wrong or anything. Let's start some that use the table instead of just the circle. So I'm gonna go ahead and write an example. So let's do, still working with cosine, let's do cosine x equals, let's do positive half. And so for this one, I'm going to need my table. So I have my sine of an angle, cosine of an angle. I'll write tangent later if we need it, but right now we really don't. So 30, 45, 60, 1/2, root 2 over 2, root 3 over 2, root 3 over 2, root 2 over 2, 1 over 2. So what I'm asking here is, what angle would you plug in for this x so that cosine equals 1/2. So if I look here, I'm looking at cosine, I'm looking at 1/2. This happens at 60 degrees. So one of our answers here is 60 degrees, or in radians, that would be pi over 3. But we need to be careful here. Cosine is positive in quadrant 1, which is my 60-degree angle. However, cosine equals positive 1/2 in one more location. Cosine is also positive in quadrant 4. So let me put a note here. So cosine is positive in quadrant 1 and quadrant 4. So we not only need the angle in quadrant 1, which was 60 degrees, but we also need the angle in quadrant 4. My angle in quadrant 4 would be, this is 0 or 360. 360 minus 60 is 300. And now everything coterminal to each of these angles would also work. So I'll say plus 360 degrees K plus 360 degrees K. Just to show you in radians as well, in radians this would have been x equals pi over 3 plus 2 pi k, and x equals, let's see, this would be 6 pi over 3, so this would be 5 pi over 3. 5 pi over 3 plus 2 pi k would be the radians answer. Again, I'll take either. It won't matter to me. And so what this is saying, what we're saying when we give all these answers, and we're saying, okay, if I plug cosine 60 degrees, I get positive 1/2. If I plug everything coterminal to 60, I also get 1/2. If I plug in cosine of 300, I also get positive 1/2. And so everything coterminal to that 300 also gives positive 1/2. So for a lot of these, you will have multiple answers. I'll tell you that for sine and cosine, anytime it has a reference of 30, 45, and 60, you're going to have like 2 different answers. And it's because cosine and sine are both positive in 2 quadrants, and they're also negative in 2 quadrants. It's always going to be 2 answers for the 2 quadrants. Let's start on some sine ones. That way we can just get some other experience. But I'm going to do a bunch of these. So for my next one, let's do sine x equals, let's do -1. And so for this, for the -1, I'm going to need my unit circle. So I'm just going to bring down both my unit circle and my table that I drew. We're going to use these, constantly today. So remember, sine corresponds with the y value on the unit circle. So I'm looking for, where is the y value? -1. And that happens down here at 3 pi over 2. So I'm saying that if I plug in 3 pi over 2 as x, I can make this statement true. So x is 3 pi over 2. Also, everything coterminal to 3 pi over 2. So if I go around the circle, I can get another answer. So I'll say plus 2 pi k. In degrees, this would be x equals 270 degrees plus 360 degrees k. We'll do another one with sine using the unit circle. We'll do sine x equals 0. So where does sine equal 0? That happens here and also here. So it happens at 0. It also happens at pi. So this is one of those cases where we're only having to go half the circle around to get our new answer. So I would say 0 plus pi k. X equals pi k. In degrees, this would be 180 degrees k. Let's do some with the table for sine. So also, I wanted to mention, the sine equaling 0 is a lot like cosine, where it's that exception where instead of adding 2 pi, we actually just add pi. Let's do some with the tables. So let's do sine x equals, let's do positive a half again. I mean, I'm going to do a bunch of them, but I'll do positive half again. So if I look at my table, sine is positive 1/2 at 30 degrees. So I can say, okay, I plug in 30 degrees as my x. But also everything coterminal to this would also work. So plus 360k. But again, we have to be careful. Sine is positive 1/2 not only in quadrant 1 at 30 degrees, but also in quadrant 2, sine is positive. So the angle in quadrant 2 that has a reference of 30 degrees, meaning it also makes sine 1/2, would be 180 minus 30, so that's 150 degrees. So I would say x can also be 150 degrees, and everything coterminal to that. These are my answers. I will also write it in radians for you just to see. That would be 5 pi over 6. And if you're curious of how I'm getting that 5 pi over 6, so I'm taking and I'm saying, okay, this is pi, which could be 6 pi over 6. Subtracting pi over 6 gives me 5 pi over 6. And the reason I'm subtracting is because it's like before it. So if it comes before, then I'll subtract. Say I was looking in quadrant 3, I would have added. So that in quadrant 3, it'd be 7 pi over 6. Now we can also see some that are negative. So let's do some negative ones. So now I'll kind of flip-flop between cosine and sine. Let's do, we're on G. Let's do cosine x equals, I'm going to put a 2 out here, and then I'm going to say negative square root 3. So first, we should get cosine alone. So to do that, I'm going to divide both sides by 2. So I get cosine x equals negative square root 3 over 2. I accidentally went up. Wow, my handwriting looks so neat up there. At the top, it looks so much better. Is it maybe because I've zoomed out? Yeah, probably. Oh my gosh, look at how much I've zoomed out now. Maybe I need to go back. I need to redo it because it looks so much better up there. I know it doesn't really matter, but maybe. I mean, maybe it does kind of matter, you know. It looks nice. Anyway, okay, cosine x equals negative square root 3 over 2. So if I try to get my reference first, so cosine is square root of 3 over 2 at 30 degrees. So I can say that my reference here is 30 degrees. But we need to be careful because if I plug 30 degrees into cosine, I get positive square root 3 over 2 because cosine is positive in quadrant 1 and 30 degrees is quadrant 1. Table only shows you quadrant 1. We need the two places that cosine is negative. So cosine is negative in quadrant 2 and quadrant 3. So what we're looking for are the two angles with references of 30 degrees, but they're in quadrant 2 and quadrant 3. For quadrant 2, I'm going to do 180 minus 30, which is 150. For quadrant 3, I'll do 180 plus 30, which is 210. So I get x equals 150 plus 360k, and I get x equals 210 plus 360k. In radians, this would have been, let's see, this would be pi or 6 pi over 6. So 5 pi over 6 plus 2 pi k, and 7 pi over 6 plus 2 pi k would be my two answers in radians. And I'll also do like one more maybe for sine. Being negative. Again, I'm just trying to make sure I show you, you know, all the kind of options. I mean, I can't show you everything, obviously, but all right, let's do, this would be part H, and we'll do sine x. Let's put a square root 2 in front of that. Here, let me write it a little nicer. We'll do square root 2 sine x equals, let's say, negative 1. There's really a lot of things we can do here. I can even make it, I can change it a little bit. Let me do plus 1 equals 0. Okay, I've settled on this. Let's do this one. First thing is we need to get sine alone. So I'll move my 1 over. So now I have square root 2 sine x equals negative 1. And then we can divide by that square root of 2. And so I have sine x equals negative 1 over square root 2. Don't let this fool you. This is the same as negative square root 2 over 2. The only thing is with the square root 2 underneath, it's not rationalized. What we usually see, square root 2 over 2, is just the rationalized version. So it's like the simplified version. So I'll write this again, sine x equals negative square root 2 over 2. And so sine is going to be negative in quadrants 3 and 4. my reference here is 45 degrees. So I'm looking for the angles with references of 45 in quadrant 3 and quadrant 4. In quadrant 3, it's going to be 180 plus 45, so that would be 225 plus 360K. Quadrant 4 would be 315 plus 360K. And of course in radians, let's see, this would be pi or 4 pi over 4. This would be pi over 4. This would be 8 pi over 4. So 4 pi over 4 plus pi over 4 is 5 pi over 4. 8 pi over 4 minus pi over 4 is 7 pi over 4 plus 2 pi k plus 2 pi k. Let's do some tangent. We haven't done any tangent ones yet. So let's see. We're going to do the whole alphabet here. So let's do some tangent. We'll say tangent x equals 0. And I'll probably do maybe like one other one for tangent. Maybe one or two more. I'm trying to drag down my stuff. So remember, tangent is sine over cosine. So if I look here, this would be, for tangent, would be 0 over 1, which is 0. 1 over 0, so that's undefined. 0 over 1, so that's 0. 0 over, negative 1 over 0, so that's undefined. In my table, if I want to add a tangent section in, this would be 1 over square root 3. This is 1, and this is square root 3. So I'm looking for everywhere that tangent equals 0. So that happens right here and here. So that's at 0 and pi. I would say 0 plus, since I only have to go half the circle to get to my next answer, I would say plus pi k. This is x equals pi k for my answer. In degrees, we would say 180 degrees k. Something else to think about is the period for sine and cosine is 2 pi. So we're like always adding 2 pi. But then for tangent, the period is just pi. So we just add pi. I'm going to do another one for tangent. So let's do one with the table. Let's do tangent x equals, I'll do like a positive and a negative one. So let's do square root of 3. So tangent is square root of 3 at 60 degrees. So my reference here is 60 degrees. And tangent is positive in quadrant 1 and quadrant 3. What's interesting here is that you only have to go half the circle to get to your next answer. You only have to go half the circle to get to your next, and so on and so forth. So this one, we actually don't have to write both answers. We can just say 60 degrees plus 180 degrees k. And that's a fine answer. Now let's say you wrote me both answers and you said in quadrant 1 it'd be 60 degrees plus 2 pi k, and then in quadrant 3 that would be 180 plus 60, which is 240, plus, ooh, I should make that 360 since we're in degrees. Let's say you write your answers for me split up like this. This is fine. This is also correct. It's not the best way to write your answer, but it's not technically incorrect. It's just not, it's not very nice, but I wouldn't take off points for something like that, but I might let you know, like, it's not really the best way to write your answer. And let's do a tangent where it's negative. And I'll make this one kind of like a solving one, how I've done before. Let's do 3 tangent x equals negative square root 3. Let's do that. Divide by 3 to get the tangent alone. So I have tangent x equals negative square root 3 over 3. You should try this one yourself, of course. Hopefully you've maybe done that already, but if not, that's alright. So tangent, be careful here. Square root 3 over 3 is the same as 1 over square root 3. It's just rationalized. So this is happening at 30 degrees. So 30 is my reference. Now tangent is going to be negative in quadrants 2 and 4. Here, let me draw it a little better. So 2, 4. So I'm looking for my references of 30 degrees in 2 and 4. Since they're only half a circle apart, I can just add 180 to get to the quadrant 4 answer. So I'll just write my quadrant 2, which would be 180 minus 30, so 150 plus 180 degrees K. In radians, it would be 5 pi over 6 plus pi K. And so again, the reason you don't have to write out both answers like with sine and cosine is because it's exactly one, like half a circle across from each other. So tangent is kind of nice in that way where you only have to write one answer and then just use plus pi k. So in general, let's talk about in general. These are the general forms. So if you want to solve something that is sine x equals some value, your angle answers are sine inverse plus 2 pi k and pi minus sine inverse plus 2 pi k. You're welcome to memorize these general forms. I don't like to do it that way. We use reference angles, so I don't really see it. I don't think it's necessary. The only reason I could see it be necessary is if you have something that's not on the unit circle. Like if you've got a weird angle or something that you're working with, then I would say yes, it's necessary. But we're working with the unit circle, so, and reference angles. So let me show you this for a second, this inverse way of doing it. So if I go back to like a sine equation, let's look at h for a minute. If I had put in sine inverse negative square root 2 over 2, the answer that it would have given me would have been negative 45 degrees, which is 315. Then if I had done pi minus negative 45 degrees, that's pi plus, so that's why I get the, or 180 plus, so that's 225. So it's like inverse can give you one of the answers. Either, be careful, inverses can only give you 1 or 4. 1 if it's positive, 4 if it's negative. And then the pi minus, the inverse, gives you that second answer. Let's talk about cosine in general. So cosine x equals y. So this would be, write it a little lower so it doesn't get confused. So this would be cosine inverse plus 2 pi k would give you one of the answers. And then if you want the second one, it'd be 2 pi minus cosine inverse. And this is what we did, like when we did, let's say for a second, let's go back and look at that, like cosine 1/2. So cosine inverse 1/2 would have given us 60 degrees. And then we did 360 minus 60 to get 300. So like we were doing the general form, I just was using reference angles to show it. And then if we have a tangent equation, this one is written as plus or minus tangent inverse of y plus pi k. I don't really think it's necessary to have that, but because adding the pi k gets rid of the, like it gives you that second answer, so I have to say I don't totally think it's necessary to write it that way. But those are those general forms. So if we ever had anything that like didn't have a reference of 30, 45, or 60, then yes, we would use the general forms. But we're always having those references, so we don't have to worry about that. So next in this section, I want to talk a little bit about reciprocal functions. I don't think we have to do very many. I'll just say example 2. I'm still just going to say solve for all values of x. And I'll probably do like 2 of these. So let's do, we'll do a cosecant one. So we'll do square root 3 cosecant x, we'll say plus 2 equals 0. Do that one. And I'll do another one too, but I need my table. So I'm going to bring that down for us. Bring it over some. Okay. I'll solve it for cosecant first, so I'll get everything on one side. So I have cosecant x equals negative 2 over square root 3. So I subtracted the 2 and then divided by square root 3. Now, my preference for these is not to really worry about the fact that it's a reciprocal and just switch it to whatever it's the reciprocal of. So cosecant is a reciprocal of sine, so I can flip the other side, and now I just have sine x equals negative square root 3 over 2. So whenever you're faced with one of the reciprocals, don't freak out. Just change it to whatever it's the reciprocal of, and then flip the other side. The reason this works, like the actual like logic behind it, is that cosecant is 1 over sine x equals negative 2 over root 3. So you can flip both sides of this. So that's what's really happening is we're flipping everything. We're flipping both sides. So when you get that flipping of the left side, that's how cosecant turns into sine. The flipping of the right side just flips your actual fraction. So now sine is square root 3 over 2 at 60 degrees. So my reference is 60. Sine is negative in 3 and 4. So my answers here are going to be 240 plus 360k and 300 plus 360k. And in radians, this would be pi over 3 pi over 3. This is pi over 3. So it would be 4 pi over 3 plus 2 pi k. And then this would be 6 pi over 3 minus pi over 3, 5 pi over 3 plus 2 pi k would be radians. That might actually be all that I do reciprocal wise for now. I'll do another one a little bit later. But all you really need to know for the reciprocals is that you just flip it. So hopefully not too crazy. Hopefully you're like, oh, not that bad then. I feel like it always looks a lot harder than it really is, you know. Alrighty, let's see. What are we pushing? I think we're at like 42 minutes. Yeah, this is a pretty long section. So I'm gonna say that we are gonna split it, but I'm not quite done yet. But I will split the video into parts. So for my next little part here to do today is I want to talk about what if it doesn't just want all values of x? What if it gives you an interval? So sometimes these questions, I'll say example 3, will say something like solve for x where x is between 0 and 360. Something like this. They could also maybe say that it's 0 to 2 pi. They could do something like that. So if they give you the interval in degrees, then they want degrees. So be careful about that. Then you'll have to make sure you put your answer in degrees. If they ask for your interval in radians, then make sure you give your answers in radians because that's what they're giving you, so that's what they want. The only difference here is that you don't have to do the plus 2 pi k or plus pi k. So let's see some of these. So I'll do, to be honest with you, there's only so many of these we can really do. I'll do a, let's see, what have I done already? I've already done a sine 1/2. Let's do one where it's sine negative 1/2. Okay, let me figure out when to do that. So if I do, let's do 10 sine x plus 5 equals 0. And I only want values of x between 0 and 360. So if I subtract 5 onto the other side, I get 10 sine x equals negative 5. And then I can divide by 10. So I get sine x equals negative 5 over 10, which simplifies to sine x equals negative 1/2. So sometimes, you might need to simplify it to get it to look like something you're used to. Sine is negative in quadrants 3 and 4. And my reference here, if I go look at my table, sine is 1/2 at 30 degrees. So I'm looking at references 30 and 30. So I get x equals, this would be 210 in quadrant 3, and it would be 330 in quadrant 4. And I don't have to write anything else because it only wants answers between 0 and 360. So I don't need to think about anything coterminal, because if I think about anything coterminal, I'm not going to be within that range anymore. And in radians, this would be 7 pi over 6 and 11 pi over 6 would be my answers in radians. I honestly love doing these equations and stuff. I think it's fun. Let's do another one, part B. Let's do one with tangent, since tangent's kind of that weird-ish one. Tangent x equals -1. So negative. Alrighty, be careful with tangent being 1. Sometimes people will try to use like the unit circle one with all the ones and zeros and stuff for sine and cosine. But be careful, tangent is 1 at 45 degrees. So if you go look at your table up here, tangent is 1 at 45 degrees. A lot of times people, when they see the ones and zeros, they go straight for this. But you have to be careful. Tangent does not equal 1 in any of those spots. Tangent's only either undefined or it's 0 on the quadrantal angles. So you got to look in your table for that tangent being 1. So tangent equals 1 at reference of 45 degrees. It's negative in quadrants 2 and 4. My answer in quadrant 2 would be 180 minus 45, which is 135. My answer in quadrant 4 would be 360 minus 45, which is 315. And you don't have to do any kind of plus anything because we just wanted answers within 0 to 360. And you had to list both of them for the tangent now, because before, the reason you didn't have to list them both is because when you added that pi k, you would get the second one. Now, since we're not adding anything, we have to just list them out. For radians, this would have been 3 pi over 4 and 7 pi over 4. Alrighty. And so just a demonstration real quick of how I'm getting those. This would be pi or 4 pi over 4 minus pi over 4 is that 3 pi over 4. This would be 2 pi or 8 pi over 4 minus pi over 4 would get me 7 pi over 4. So that's how I'm getting those radians answers. Then I'll do maybe one more. I'll just do like a secant one. That way we have some experience with secant as well. We'll do secant x equals, let's do -2 over √2. Something like this. Because it's the reciprocal, I'm going to flip it to cosine and then flip the other side. So -√2 over 2. I already did so many negatives. Let's just do a positive one for this one. Let's just do positive. Sorry for switching it up on you. I just felt like I've done too many negatives. My reference is 45 degrees. Cosine is positive in 1 and 4. So my answers, 45 degrees and 3/15. In radians, it'd be pi over 4 and 7 pi over 4. Okay, so this is going to end like part 1 of the solving equations. In the next part, I'll talk about what if the parentheses don't just have x, like what if they have other stuff. And then we'll also talk about maybe using some identities, and we'll also do some quadratics. I'm not sure if I'm going to put that all in one video or not. I'm just going to try to look at the time. I don't really like to go over an hour or so. Alrighty, well, I will see y'all in the next video. Hope you have a great day.